Okay guys, welcome back. We're going to look at the next section today, which is isosceles and equilateral triangles. So these should be some words that maybe you guys recognize from the past, but we're going to look a little bit deeper into them. So just remember, isosceles triangles have at least two congruent sides. Now we're going to look at some specific sides and names of these different parts. Okay, so isosceles triangle has two sides that are the same. So in this case, those are going to be our legs. So our two legs are going to be congruent. Okay, and that right here and right here. The one side that's not congruent is called your base. Okay, the two angles that are created with your base and the leg are what are called base angles. And we're going to see here in just a second a theorem about those. And then the very top is what's called the vertex. Okay, and these are all considered vertexes, but the one that is not part of the base is the actual true vertex for this thing. So here's what these theorems say, and these are very important to understand. The first one, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So we said already, for things to be isosceles, those two legs have to be congruent. What this says is the angles opposite those, so our two base angles, are also going to be congruent. Okay, now, the converse is the exact opposite. What that says is if two angles are congruent, so we're talking now these two angles, then the legs or the sides opposite them are congruent. So what I want you guys to start looking for is if you have two sides or two angles of a triangle being congruent, the opposite sides or angles, whichever it may be, are also congruent. So those are really important properties to understand. Okay? So like I said, let's say this was 30 degrees, this was 25 inches, this was 25 inches. Because these two lengths are both 25 inches, that means that this one would have to be 30 degrees as well, and vice versa. Okay, so those parts are true, part of that theorem. Alright, so let's see if we can figure this out. Now in these two examples, all they want you to do is to name the parts. Okay, nothing more than that. They're not asking you to solve, they're just asking you to name the parts. So name two congruent unmarked angles. Well, the only way that two congruent unmarked angles could be true is if their sides opposite of them are marked. Well, if you look at here, I've got CB congruent to BA. So those are my two sides there. Okay, and so based on that, sorry, I didn't mean to do that. What I end up seeing is that the angles across from them are going to be congruent. Okay, so what that tells me is that angle A is going to be congruent to angle, we're going to have to call this BCA, since angle C can be a couple things, and so there is your two unmarked congruent angles. Now the same idea holds true for sides. I want to know what are the two sides that are unmarked that are going to be congruent. Well, if you notice here, you've got this angle and this angle, which are going to be congruent. So opposite those would be here and here. So what that means is that side CB is going to be congruent to side DB, and those are your congruent sides. Alright, and that's how isosceles triangles work. We're going to see where we can solve some problems with those properties, but that's what you're looking for, the sides or the angles opposite. Alright, equilateral triangles. Equilateral triangles are all these sides are the same, and the only way that those things can be equilateral is if it is also equiangular, meaning all the angles are the same. And the only way that's possible, if you think about it, they've got 180 degrees divided by three angles, they all have to be 60 degrees. So in an equilateral triangle, all the sides are the same, all the angles are the same, and all the angles are 60 degrees. Alright, so this first example here says find the measures of angle Y and Z. Well, a couple ways to look at this. You've got 8 inches on both of those sides. That means it's an isosceles triangle, which means those two have to be the same. Okay, we don't know what they are, but they have to be the same. Well, if they're the same, I've got a 60, an unknown, and an unknown, and all of those, so the 60, the unknown Y, the unknown X, which we're going to call Y because it's the same, have to add up to 180. So solving this out, I subtract 60 I got 2y equals 120, divide by 2, y equals 60 degrees. And so what that means is those two angles have to be 60 degrees, which should make sense because they are an equilateral triangle, which means they all have to be 60 degrees. Alright, so where can we use some more of this? How about right here? Find the measures of angle M and side PN. Well, let's look at the easy one first. If you see you got angle P right here, you've got angle M right here, they're congruent. That means their opposite sides have to be congruent. Well, P's opposite side is 11. That means that M's opposite side would have to be 11 also. So side PN is going to be 11 centimeters. And we got that one figured out. Okay, now what we're looking for is angle M. Well, because we already saw that these two things are congruent, that means that all three of these have to add up to 180. Well, I have 180 minus the 120. That leaves me with 60. Well, those 60 would be split between those two, so that means angle M would be 60 divided by 2, or 30 degrees, and there's your final answer. Okay, what I want you guys to do is pause the video, give this one a try, come back and see what you end up with. Okay, so in this problem, you can see that these two angles here are both 2x. Now, since they're the same, it's going to help us out here in a second. I also can see that I have these line markings, and that means that their opposite sides are going to be congruent, so those two have to be congruent. Well, since that angle has to be congruent to this angle, that means that that one has to be 2x as well. Okay, so that angle right there, this angle right here, is 2x. Well, since they're all the same, that means that this has to be an equiangular triangular. So an equiangular triangle means all three of them are 60. So I've got 2x equals 60. That gives me x equals 30. And there you go. Alright. This value here, I think I may have left a number off. I apologize for that. But because they're all the same angle, that means that all the sides have to be the same. So if this one were, let's say, 30 degrees, I could solve this and this just by saying they have to be equal. So 4y minus 5 equals 30 degrees, and start solving. So add 5 to both sides, giving me 35. Divide by 4, and so y equals 35 fourths, and there you go. Alright, to finish this up, I want you guys to take this example. I want you to solve for the variables, and this will be our discussion in the next section. Okay, so right now we're in topic 5. On topic 6, we'll discuss this solution. So give it a try, and we'll go from there. Okay, talk to you soon. If you have questions on your assignment, let me know.